Well, you'll definitely want to read the chapter before you watch the video here. So don't forget to do that. So here's our first look at this section, and here's our first example in 4.4. And we really have three different things to fill in here. The first one is, well, first let's see what we have. We have three different countries, France, Mexico, and Russia. We have the population of two of these countries. We have the number of people living with AIDS for two of these countries. And we have the percent of people living with AIDS for two of these countries. So we want to fill in this here first, which is right here. So this is from the last section, really. So what I'm going to have is, here's the ratio of people living with AIDS. It's 326,166 people living with AIDS out of a total of 65,233,271. So there's our ratio of people living with AIDS. But what we want to do is make a new equivalent ratio with the denominator of 100. So these will be equal ratios, but this will be expressed as a percentage. So we're going to cross multiply and divide, and I think by now you can do that. And why don't you put it on pause, and I will put up the answer. And when I do that, I get 0.4999, repeating and a bunch of numbers. Rounding it to the nearest tenth would be 0.5. So that's 0.5. X is 0.5. So that's 0.5 over 100, which is 0.5%. In other words, there's a half a person out of every 100 that has AIDS. Another way to look at it is that there are one person for every 200. So for Mexico, we need to find this, which is the number of people living with AIDS. We have the total population, and we have the percent. So let's do that one next. So in this case, we're still going to use a proportion. But what is unknown is something different than the last problem. What's unknown is how many people are living with AIDS. But I do know the total number of people. And the other thing I know is I know that the percentage. I know that there's 0.3 people for every 100 living with AIDS. So again, I'm going to cross multiply and divide. And I will again put up the answer. But we want to put it on pause and make sure you can do that. But understand what I'm doing here. So there's 0.3 people living with AIDS out of every 100 people. Over here, I don't know how many people are living with AIDS, but I know how many people total. Of course, this one we want to round to the nearest whole number, because you can't have a half a person with AIDS. You can have a ratio with a decimal, but not an actual number of people. So I'm getting 392277, or 392,277. Now our last problem is we're going to find the population of Russia here, based on the information that we know. So again, we know how many people are living with AIDS. But I don't know what the total population is. But I also know that an equivalent ratio is, I know that for every 100 people in Russia, 1.2 of them has AIDS. So that's the proportion. Two equivalent ratios. And I'm going to solve for this one. And that's going to give me the population of Russia. Again, I'm going to cross multiply and divide. I'm going to give you a second to pause it here, and I will put up the answer. And you should have gotten like I got, which is 143 million people. And 964,667, rounded to the nearest whole number here. So the population of Russia is about a little bit more than half that of the United States. Actually, Russia's population has been decreasing recently. So now we're on example 4.17a. We're going to determine the population of each age group using the birth rates. And you see the birth rate is per 1,000. To compute the number, we're going to do 15 to 19-year-olds, which is right here. And we can either use the rate of either 22.3 or 24.2, depending upon what year we're talking about. So let's stick with year 2015. So I'm going to use the rate of 22.3 births per 1,000 women. That's the rate. It's not really explicit here, but that's what it is. And I'm also going to use the absolute number of the number of births, that the number of babies that were born to that age group is 229,888. Now recall that that is not, this is specific to this age group. Right? I have the total births in that age group, and I have the rate at which that age group is having babies. So I'm going to set up my problem here. 22.3 births per every 1,000 women in that age group. So if there was 229,888 births, then what is the total amount of women in that age group? Which is going to go right here, the population of that age group. You can see that. So I'm going to cross multiply and divide. So I'm going to get 22.3 times x equals 1,000 times 229,888. And then I'm going to divide both sides by 22.3. Now I'm going to keep this here because that's what x equals. I'm going to find a number, put it on pause, make sure you can do this. I'm going to find a number, but I'm going to use this right here. Everything that I just did here, right there, for my Excel equation, because I'm going to put in how you would do it with Excel. So when you put it on pause, make sure you can do that, and I'll write the answer down. So the answer I got is 10,308,879. So that's solved. That's how many women. That would go right in there. That's how many women there are in that population in 2015. Now in Excel, to find that number, I would say equals, and I would put it in this cell here, in C5. That's the cell I'm putting it in. And I'm going to say equals, and I got 1,000, which is never going to change, right? Because that's part 22.3 over 1,000 is never going to change. But and it's always going to be 1,000, so it's going to be 1,000 times the 22.3 is F5 which is going to be over here. But this is going to be 1,000 times the number of women that gave birth, which is going to be B5. I'm going to put all that in parentheses, and then I'm going to divide it by the 22.3, which is F5. That's what's going to be in the cell there. Of course, you would probably just start out in the cell up here, which is E4, and then run it down like that. So here's a thought question. And we're looking for the populations of these age groups, which we just did, right? And the thought question is asking, could I have used these percentages instead of these rates? And the answer is, well, let's think about it. Couldn't I just have said for the 15, the one we just did, getting this number here, could I use this 5.78%? Well, what is that 5.78%? That 5.78% is of the total births, 5.78 of them out of every 100 births total was women aged 15 to 19. Well, births, 5. Births per total number of births is not going to get you to the population. You can see that, right? Births for 15 to 19-year-olds, 5.78 per every 100. And I have then how many women, 15 to 19 per 3 million total births, but I don't even have the population. So this is not going to be useful in determining the population. What we did on the last slide, using this number here and this number here, and understanding what this means, is the best way of doing that. So here we're going to compute the births as a percentage of the 25 to 29 age group. So there's the 25 to 29 age group right there. We're going to want what percent of that age group had babies. Now this is the percent of births total. In other words, this 28.98 here percent means that 28.98 births out of every 100 births came from this age group. So all these numbers, when I add them up, I got to add up to 100%. Because this part came from this age group, this percentage came from this age group, etc. But here I'm asking a completely different question. I'm asking you what percent of that age group had babies. So, and here's the answer right here. That many babies from that many people in that age group. So it's really a pretty simple problem if you see it. But it's going to be 1,152,650,660 divided by that's births per total population, and then I want births per 100. So let's just set up the proportion. Okay, so here we go with this one. We've got 1,152,660 births. I'll put V for births. Out of a total population of 11,051,390, it looks like. And that's the total population. So this is how many births there are. This is the ratio of births to population. So the percentage of the age group is simply this ratio. But we want to rescale the ratios so that the bottom number is 100. And of course, you all know how to do that. Cross multiply and divide, and put it on pause, and you can figure it out for yourself. And I'm getting 10.4. So 10.4 over 100 is 10.4%. So what that means is that 10.4% of the women 25 to 29 gave birth during that year. So the Excel formula is going to be, and for the Excel formula, you kind of have to go ahead and cross multiply and get X by itself. So I'm going to go ahead and cross multiply this times this, and then this times this. So if you can see it, it's going to be 1, 1, 5, 2, 6, 6, 0 times 100 divided by 11051 390. Now hopefully you can see that. If not, do it the long way. So now for the Excel formula, in this cell, which is cell E7. So I'm placing it in E7. And it's going to say equals. That's how you start all formulas. And then you're going to go, this number here is over here. So it's equals B7 times 100. I'm going to put that in parentheses. And then divide that by C7. And I would, after you do that, I would then make it a percentage by hitting the percentage key. Or that will be a percentage. That will be the percent. Okay. Okay, so this is our final example, 4.19a. And this is from the book. And this is different states and the percentage of people with bachelor's degrees in that state, and then the number of bachelor degrees in that state, which is there. So what we're going to find is the number of residents 25 and older in Georgia, because this is just tracking the number of residents 25 and older, okay? It says right here, population 25 years and older. So what we have in Georgia, it's hard to see, it's down about right here. Georgia has 28% of its population. That means 28 out of 100 have bachelor's degrees. I'm going to put D for degrees and P for people, greater than 25. So for every 100 people 25 and older in Georgia, 28 have bachelor degrees. Well, we know that there's 1.77 million, and that's times 10 to the 6th, bachelor's degrees. So from that, what is the total number of residents 25 and older? So you want to, this is a proportion, and we want to make this ratio here equivalent to this ratio here. And in doing so, we will tell and know how many residents there are over 25. So this is cross multiplying and dividing, and you can do that. Pause this and see if you can get the correct answer. So when I cross multiplied and divided, I got that answer. Another way of doing it is algebraically. And there's another way. I mean, you should know that the number of residents is going to be larger than this. And the only other number you have is this here. By the way, 28 out of 100 is 0.28. So you could say, if you wanted to make an algebraic equation, is to say that 0.28 of the total population 25 and over, 28% of that is equal to 1.77 times 10 to the 6th. And then divide both sides by 0.28. Divide by 0.28. And you wind up with this here, which is exactly the same as if you cross multiplied and then divided. Okay, so if you're going to do Excel, you would start out with an equal sign, and then you would have 1.77 times 10 to the 6th, which is in the millions over here, in the column, the count, the number, and then times divided by 0.28, which would be divided by another cell, right? And the cell would be, you would have that 28% in a cell. So the point is, with Excel, you've got to work out the problem to an extent before you start putting in the formula. Okay, so this is some of the homework, and I just want to clarify a couple things. Like, for instance, when it says 1.2, you're making a fraction, which here you're given a fraction, and you need a decimal and a percentage. And of course, they're all equivalent, right? So let's do this one here. The decimal is 0.08. The percentage is going to be, this is 0.08 over 1, right? You can write any number over 1. So if you multiply the top by 100 and the bottom by 100, you can either put that in your calculator or understand that it moves the decimal 2 places. So there's your fraction. And here's your percentage. So that fraction you can put here, and the percentage you can put here. Now 1.2, let's look at that one. 1.2 means 1.2 over 1. So we're going to make it a percentage and a fraction, multiply the numerator and the denominator by 100, and you get 120 over 100, which is 120%, and there's your fraction. Nobody asked you to reduce it. And remember, 0.9% means 0.9 over 100. So there's your fraction, and the decimal, you can just put it in your calculator, and you're going to get 0.009. Dividing by 100 moves it 2 places, right? So I just want to get you started on 2. There's 3 different charts. In this one here, you are finding out the percent that live in poverty. In this one here, you're trying to determine the number that live in poverty. We should go here. And in this one here, you're finding the total population of the state. Now, all the numbers are in thousands. See that? That's important. All numbers in thousands. So I will just do a couple of these for you. So first we'll do the percent living in poverty. Now, if they're both the numerator, well, let's just do it. So the number in thousands is 784. I'll do right here. 784. Oops. We have 784,000. That's living in poverty over the total population, which would be 4,820,000. And actually, because the numerator's in thousands, and I can reduce the fraction this way, right? So I even can make my calculator work a little easier. I didn't even need the thousands for this one. So it's just 784 divided by 4820, move the decimal 2 places, or set up a proportion. Cross multiply and divide. And I'll let you do that. So this one here, I have the percent living in poverty is 16.2 people living in poverty per every 100 people in the state. So part to total. And for the number of people living in poverty, I don't know. But the people living in the state would be 20071 and 3 zeros. So if you want to know the actual number living in poverty, not the number of thousands, you would do it that way. And then you just repeat that. So here I have the percent living in poverty, and I have poverty total, part total, and then I have the number living in poverty, 3251000 over I don't know. Cross multiply and divide. So this technique of cross multiplying and dividing can be used for all these different kinds of problems. I'm going to go over 3 a little bit, but 3 and 4 are remarkably similar to what we just did. It says 30% of students, which I'm going to write that right down, 30 over 100. 30% of students are absent due to the flu. If 40 students were absent due to the flu, how many students attend the school? Well, there's 30 absent due to the flu for every 100 students. So I had 40 absent due to the flu. So how many students do I have? So cross multiply and divide. See, another proportion, 2 equivalent ratios. These problems 5, 6, 7, and 8 are more reasoning problems. So here we have motor vehicle deaths from 2013 to 1913 to 2016, so over 100 years. Was it more dangerous to drive a car, that's supposed to be car, not can, in 1970 than it was in 1920? Explain. Well, let's look up here. 1970 is about here, so there were about, I don't know, it looks like about 55,000 deaths in automobile accidents in 1970, where in 1920 there was maybe 10,000. So looking at it one way, you can say there was a whole lot more deaths in 2016 than there was in 1920. But is it more dangerous? Well, this is the problem with just raw numbers. Here's some of the situations you have to think about. First of all, how many people were there in 1920 versus 1970? There's a lot more people in 1970. How many more automobiles were there? Well, there's still horse and buggies back here, so there wasn't that many. But here, there was millions. So this is not a good way to analyze data with the raw numbers. I need a comparison. I need a rate. So down here, I'm given a rate. Deaths and motor vehicle rates. So the red line is just the number of deaths, which is the same as this one here. The green line is rate per 10,000 motor vehicles. So that's the green line here. And the blue line is the rate of death per 100 million miles driven, which is similar to the blue line, similar to the green line. A little bit of a difference perhaps, but not many. So to go back to question 5, the answer would be no. The rate per 10,000 motor vehicles, the death rate per 10,000 motor vehicles was a lot higher in 1920 than it was in 1970. Notice also the rate's been dropping steadily. The rate per 10,000 motor vehicles or the rate per 100 million miles. So with that, I'll let you work on 6, 7, and 8. And some of it's just applying some reasoning to it.